Hello class. Today's lesson is a continuation of yesterday's lesson on exponential growth and decay. And today we're going to talk about applications with exponential situations. This is notes 411, so make sure you have your notes out. And let's go ahead and get started with this lesson. Alright, at the beginning of your notes it says we'll be graphing today and resetting the window frequently in our calculator. Just keep in mind that the X represents the time and the Y represents an amount, some sort of amount. It depends on the units that we're using in the problem, and those units will change per problem. Okay, alright, so let's go ahead and get started. Look at example 1. It says $300 is invested in an account earning 5% interest. Since it earns interest, we know that it's going to be a growth situation. And that growth is compounded annually. What we're going to do is write an equation in the form of y equals a times b to the x for the amount in your account after x years. So let's use the formula that we learned yesterday. That formula is y, this is for growth and decay, equals a times b to the x power. Now that b is going to actually be 1 plus your growth or 1 minus your decay. Alright? Since this is growth, we're going to be adding. So we're going to add 1 plus 5% is 0.05. So our b is going to be 1 plus 0.05 or 1.05. That's going to go in place of the b. The a, if you'll remember, a represents our initial amount or the y-intercept. Right, so that initial amount or y-intercept in this problem is $300. Alright, so let's go ahead and plug in what we know. We know that the equation is going to be y equals the initial amount is $300. I'm going to use parentheses for multiplication. My b is going to be 1.05 because that's 1 plus the growth of 5%, and that's going to be raised to the x power. Okay? Now what we're going to do is we're going to use the calculator to find some things out about this problem. So let me pull my calculator in here. Alright. Let's go ahead and enter this calculator, the equation into the calculator. So I'm going to go to y equals, and I'm going to type in 300, put my parenthesis, 1.05, close my parenthesis, and then I'm going to use the caret key, the one that's underneath clear, and that gives me my exponent, and now I'll put the x in there. So raised to the x power. Okay, and now we can go and look at the table. So let's look at the table. Second and graph gives me the table, and what it does, it gives me my values. It tells me in the on the calculator, it tells me after 0 years, which is our initial amount, it's $300. After the 1 year, it's going to be $315. Say I made $15 that first year. In the second year, it's going to be $330, third year, $347, and so on. The problem asks us, how many years will it take for the investment to double? So double, if I double 600, remember doubling is multiplying by 2. So if I take the 300 and I double it, hopefully you don't need your calculator for that, and that would be 600. So I want to find out when what x is when the amount is 600. And if remember, the amount is our y, so I'm going to look in the y, over here in the y column, and I'm going to go down to 600. So I'm going to go down until I get to 600 in the y. And it's quite a ways down here, but it's getting there closer. Alright, so if you look, I don't have it 600 exactly, but it falls in between 14 and 15 years. So it would be, I would say, between 14 and 15 years, or it's not going to be 14, so I would just use the larger of the two. Oops, not 14 minutes, but 14 years. 14 and 15 years. So I'm going to say 15 years for it to double. Okay? Pretty simple there, alright? Let's look at example 2. Caffeine is eliminated from the bloodstream at a rate of 12% per hour. All right, since it says eliminated, eliminated, that would be, it would be going away. So that means this is going to be a decay problem. Okay, so it's going to be a decay problem. Oops, let me get a better color there. So my B I'm going to subtract instead of add. My rate is 12%. So to find my B, I'm going to do 1, in this case since it's decay, minus 0.12. Hopefully you don't need your calculator, but if you do, just put that in, 1 minus 0.12, and you should get 0.88. So my equation is going to have 0.88 in for B. Now the next thing is I need the initial amount for my y-intercept, and that's 150 milligrams. So now I can write my equation. I'm going to have to write down here y equals, my A is 150, and it's in milligrams, so that's my units, that's my initial amount, times 0.88, and I'm going to raise that to the x power. Alright, now since this 0.88 is smaller than 1, it means it's going to get smaller as we work. So let's get our calculator back out here, and let's go to y equals, we'll clear out this equation, and we'll type in 150 parenthesis 0.88, close my parenthesis, and I do my exponent to the x power. Alright, and if I go to the table, second table, and I'm going to arrow back up to where it gets me up to 0. And 0 should always end up being what your initial amount is, so you want to double check that. And our initial amount was 150 milligrams. If you look after 1 hour, it's going to be 132 milligrams, 2 hours 116 milligrams, 3 hours 102 milligrams, and so on. Right? What if I said how many milligrams after 7 hours? Well, I would just go to x is my time, so that's my hours, so I'm going to go down to 7, and I'm going to look, it'll be 61.3. Alright? But the question says how many hours will it take for half the caffeine to be eliminated? Alright, so I would take my 150 and I want to do half of it, so I'm going to divide it by 2 or multiply by 1/2. When I do that, it means I have 75 milligrams. So looking at my calculator, when is it 75 milligrams? Well, it's going to be between 5 hours and 6 hours. So we'll use the 6 hours since that's the, because if 5 hours would be too short, so 6 hours I'd say. So it would be between 5 hours and 6 hours. So I'll say 6 hours is when it gets there. Okay? Alright, so that makes that pretty easy. Alright, your job now is, I know you don't have, most of you don't have a calculator at home, so tonight I want you to try to set up the equation for 3 and then figure out how you would put that in the calculator when you come to class tomorrow. You can put that one in the calculator, okay? We look forward to seeing you in class tomorrow, and you have a nice evening. See you then. Bye-bye.